Hello everybody. In this video we are going to discuss about left recursion in context-free grammar, and we will see why this appears, how it affects our parser creation, and what we can do to remove these left recursion. So let's start. Now in our earlier video we have already seen that in an ambiguous grammar, in order to handle associativity, we have to introduce some kind of a recursion. So if an operator is left recursive, as we had seen earlier, so if it is left recursive, I have to write it like this, say E plus T or T. So here this is a recursion. So E is calling E. So if it is right recursive, then I would have to write it like this, T plus E or T. Okay, so in that case, here also there is recursion, but this is right recursion. Whereas in this first case, this is your left recursion. So recursion is unavoidable because if you want to take care of associativity, you have to bring in some kind of recursion. Now, when we have a recursive production, you can think of it to be something like this. A production is recursive. It is of this format: A, alpha or beta, where alpha and beta are strings of terminals and non-terminals, and beta here does not contain any, does not start with A. Okay, so our what is a alpha, beta? These are strings of both terminals and non-terminals. Okay, and beta does not start with A. Does not start with A. Then this production, we say that it is a left recursive production. Similarly, if we write it as if we have something like this, alpha, A or beta. In this case, I have recursion here, but this is our right recursion, whereas what we have here is our left recursion. Now, if we have recursion, then what is the issue? Why do we need to remove this, or why does it create problems? Let us see this. So let us assume I have a production like this, A alpha or beta. Okay. So let us see what is the language generated by this production or by this grammar. So I may choose A derives A alpha, or I may also have A derives directly beta. So if it is beta, then it stops here. Okay. If it is so we get what we got was beta is one of the strings. Okay. Or if I follow this first product set, in that case I have A, again I'll have to expand now since this is a recursive call. So I may stop at beta. So I have the string which is generated by this is beta alpha. So beta alpha. Or I may choose something like this. Instead of using beta here, I will again expand this as A alpha. Okay. So again I may choose here beta. So what I get? Beta alpha alpha. Or again I may choose, instead of this, I may choose again to expand this by using the production A alpha. So this can go on like this. Now ultimately it has to end, so somewhere it will be ending with beta. So the strings that I will get can be something like this. Beta starts with beta, and it can be any number of alpha. So we can write, that is, the language generated by this grammar would be a string which starts with beta followed by 1 or 0 or more alphas, right? This is 0 alpha, this is 1 alpha, this is 2 alpha, and this is some n number of alpha. So where n is greater or equal to 0. So this is the language generated by this grammar, beta alpha to the power n. Okay, now let's keep this and see again now what is the problem with this recursion. So I have A derives A alpha. Okay, so in a recursive function you will recall that first what we do, we check for the base case. That is, in terms of recursive programming, the base case is the terminating case. So if you reach the terminating case, then you can come out of the recursion. If it is not the base case, then you continue with the recursion. So we have in our production, we have A derives A alpha or beta. So you can think of the beta to be the base case. Okay, so now when we have left recursion, in case of left recursion, I have A which immediately calls A again. Alright, so there is an immediate recursion. A is calling A again. Again, if I expand A, okay, again A is calling A. So if it continues in this manner, okay, before it does not check for the base case. It does not check for the base case, and it directly goes on to calling itself to the recursive case. So in such a situation, we have the problem of the program running into a cycle, or what we in programming terms we call an infinite loop. The program falls into an infinite loop. Of the parser program will fall into an infinite loop. Okay, because directly after, when A is called, it directly calls itself without checking for the base case. Okay, so that is why your left recursion can create some issues which gives rise to infinite loops. So if your parser program has an infinite loop, it is not going to terminate. So if we have left recursion, then we cannot create a parser for it. On the other hand, if we have right recursion, okay, suppose I have right recursion, something like a right recursion was, say, alpha A. Oh, sorry, it's not this format. A derives alpha A or beta. So here, first we have some alpha. Okay, so this is where you may do the condition checking, or you may test for the base case. In alpha, you may test for base case. So when you are testing for the base case here in alpha, if the base case is reached, then you don't need to go to the recursive. So there is an option that you may terminate from the loop, from the cycle. So that is why in case of right recursion, the problem of infinite loop does not occur. So the issue is only with our left recursion. So let us see how we can remove this left recursion. So the recursion that we saw here was A derives A alpha or beta. Okay, this is known as your immediate left recursion. Okay, so you have immediate left recursion. Now immediate left recursion, when we have, all right, this is the one which is more commonly found in our programming languages. Like if you remember, again, E is E plus T or T. This is the expression grammar, operation grammar. So here you can see that there is immediate left recursion. We may have another type of left recursion which is known as indirect left recursion. Indirect left recursion. So how does indirect left recursion looks like? It is something like this. Say A derives B, say something like this, okay, and B derives A, something again A, and so on. So here also there is recursion. If you can see, A derives say B, then B again calls what? A. Something like this. So indirectly A is calling itself. So there is a recursion here also. But this is known as your indirect left recursion. So we have immediate left recursion and indirect left recursion. Now normally in programming languages, indirect left recursion is not seen. So we don't have to consider this particular case. So we'll consider only immediate left recursion. So as already we have seen in this here that the language generated by this production is beta followed by 0 or more alphas. So using this, we will try to rewrite this production rule in such a way that it generates the same grammar. We do not want to modify the grammar such that the language is changed. The language generated by the grammar should be the same, but still we want to eliminate the left recursion. So how do we do that? So let's see. So given a production like this, A alpha or beta, we are going to rewrite the productions as like this. We are going to introduce a new symbol, beta A dash. And what does A dash derive? A dash derives alpha A dash or epsilon. So why did we write it like this? Okay, so we are going to replace this production by these two productions. Now why did we write it like this? Again, we have written our language generated by the grammar was beta followed by alpha n, where n is greater or equal to 0. So we need that something here we have, when I use this particular production, then I'm going to write it like this. This means A derives beta A dash. So the A production now will derive the beta, and this A dash production will produce alpha to the power n. Okay, n number of alphas. So you can see A derives beta A dash. So this is for deriving the first beta that is starting, and this is for deriving the n number of alphas. So n is greater or equal to 0. So the A production now we have to produce multiple alphas. So it will produce something like this, alpha A dash, okay, or epsilon. So epsilon, because the language may have only beta. So only beta is there. So in that case, A dash will be epsilon. If A dash is not epsilon, then I have A dash will start with alpha and then it will lead to another A dash. Okay. So again, A dash, I may replace it with alpha A dash. Okay. Or again, I may give it as alpha A dash. It can go on like this until I terminate this by using epsilon. So I get a string of alphas. So A dash always is going to derive a string of alphas. Alpha to the power n. N is greater or equal to 0. And what is A going to derive? A is going to derive the string beta followed by our A dash. Sorry, here I should have written A dash. So the grammar the language that is generated by this grammar is exactly the same as the one generated by our left recursive grammar. But here you can see that there is no left recursion. There is right recursion, but as I mentioned, we do not have any problem with right recursion. So in this manner, we can replace we can remove left recursion from our productions. So let's take one example. The same grammar that we had, E derives E plus T or T. So our grammar should be of the form E derives A alpha or beta. Now which is A, which is alpha, which is beta? Let's see. So here this is our A. So this is A. Which one is alpha? Whatever comes after this. So this is alpha. And what is beta? What comes in the optional part. So this is our production is of this form. A derives A alpha beta or beta. So now how do we have to rewrite this in the form A derives beta A dash and A dash derives alpha A dash or epsilon. So if we rewrite this, so we'll have our A here is E. So E derives beta. What is beta? Beta is T. Okay. A dash. So I will have another variable here called E dash. Okay. T E dash. Then what does E dash derive? E dash derives alpha A dash. What is alpha? Alpha is plus T. Plus T is our alpha. And what is A dash? A dash is our E dash or epsilon. So here we have E derives T E dash derives plus T E dash or epsilon. So in this way we have removed the left recursion from this production. Now our grammar is ready for your for constructing a parser. Now we'll see in the next video, we will see something more about left recursion.